Hello everyone, this is Sudhanshu Sarkar, Assistant Professor, Department of Electrical Engineering, Narula Institute of Technology. Today I am going to give a lecture on power system. The subject is designed for third year electrical engineering students for 5th semester. So here in this lecture I will talk about the concept of steam power plant. This is one of the most used plant for generating electric power. So in this subject we have some lesson plan. So in module 1, this is basic concept of electric supply system. Then in module 4, electrical design of overhead transmission line. Then module 6, cables. Module 5, electrical corona. And then module 2, generation of electric power. And finally, we have tariff. So in module 2, generation of electric power. So in this lecture, today my topic of discussion is the general layout of typical coal-fired power station, or you can say a steam power station. This is the course outcome of power system 1. In course outcome, you know that there are 3 course outcome for this particular subject. The first one is the understand the concept of power system, know various power system components and define associated terms. Number 2, know different types of power generation. And number 3, understand basic performance of power system. So today's topic is under course outcome 2. That is the know different types of power generation. And today's topic of discussion is steam power plant. Then we'll talk about the very basics of the introduction for this steam power plant and general layout of the steam power plant, and its different part will be discussed for today's topic. So here, first let me talk about that what are the different types of power plants or classification of power plants which is available in the world. Let's see in a broader way. Based on the form of energy converted into electrical energy, the power plants are classified as, look, the first one is steam power plant, then you will find the diesel power plants, there are gas power plants, the hydroelectric power plant, nuclear power plant, and nowadays the solar plant, the wind plants, that is also available in the market. So my today's topic of discussion is basically design on the steam power plants. Now, what is actually the steam power plant? Let me talk about that first. A steam power plant converts the chemical energy of the fossil fuels into electrical energy. What the power plant is actually doing, the steam power plant, it is actually converting the chemical energy of fossil fuels into the electrical energy. So what are the chemical energy of fossil fuels? The coal, the oil, and different types of gas. These are the chemical energy. Or the fossil fuels, under the fossil fuels you will get the uranium, the thorium, etc. So from the chemical energy of the fossil fuels to converting in the electrical energy is the main property, or you can say the main objective of steam power plant. Now look, the steam power plant basically works on Rankine cycle. You all know about the Rankine cycle. Steam is produced in the boiler by utilizing the heat of fuel combustion. The steam is expanded through the steam turbine. Yes, so the figure is there. The steam turbine drives the generator which converts mechanical energy of the turbine into electrical energy. So in this way, basically, the power is generating. So where the steam is producing, the steam produced in the boiler by utilizing heat of fuel combustion. The steam is expanded through the steam turbine. Okay, the steam turbine drives the generator, which converts mechanical energy to the electrical energy. So this is very helpful and very useful concepts. Look, the procedure of steam production is the main purpose. So there is a water treatment plant, and the first, with the help of the coal or some other fossil fuel, heat generated, and that heat converts the water to the steam. That steam goes through the pipe, and that steam give the pressure to the blade of the generator or alternator, and then it starts rotating, and that rotation actually producing the electric power, and it's a conversion from mechanical energy to the electrical energy. So this is the process to producing the power for the steam power plant. So here it's the boiler, then the turbine work out. The first one is pump, the heat out, then the boiler giving the heat, then the turbine rotating. So this process is there. This is called the Rankine cycle. Now, sometime when you are traveling through a train or bus, you will find this type of construction: the cooling tower, the stack, the turbine, the general layout of a physical power station, that is, you can say, the steam power plant. Now let me talk about the modern steam power plant layout. So coal storing, then we'll find coal handling plant. If you go to any power plant, you will get this layout. As an electrical engineer, you have to understand this first. So the ash storage, from the boiler, the ash is generating, and the ash handling plant, ash storage is there, which is used to make different types of material like cement. Then coal handling plant, the boiler, then we have the chimney, the air preheater, then flue gases, the air is coming. The economizer will be there. Then there is a boiler. So boiler to it's coming to the supply, superheater, economizer, and then male valve, the turbine. Then it is connected to the boiler fed pump. So the system is, it's a very systematic way producing the power. It's the cooling tower, so is the condenser, and then finally look, the generator is there. Is the turbine, main valve, and from the generator the three-phase supply is connected, and through the three-phase supply the power is producing. And you all know that the Indian standard generating voltage is 11 kV. Then outside the plant, inside the plant, there is a power transformer. With the help of this power transformer, it convert the voltage level from 11 kV to 132 kV, or sometimes 220 kV, or sometimes 440 kV, 400 kilovolt, and then it's transmit. That is the other part. So this is the general layout of, and the basic layout of the modern power plant. And the same figure is present here, the modern power plant layout. The coal storage, and then the coal handling plant, the ash storage, okay, the boiler, the handmade steam power plants, flow sheet, and finally the condenser, canal, river, or sea. The alternator is connected here to the alternator. The bus bar is also connected. So this layout we have to understand. Now inside the layout, you will find these major parts, the major component of steam power plant. So there is a boiler, then superheater, the reheater, then air preheater, economizer, steam turbine, condenser, cooling tower, circulating water pump, boiler fed pump, generator, water treatment section, chimney and control room. So these are the part was there in the last figure in the layout of the thermal power station. So this is actually the major components of steam power plant. Now in steam power plant layout, if you follow it very carefully, you will find the modern steam power plant mainly divided into 4 circuits. What are the 4 circuits? Today I'm going to talk about that 4th circuit only in this particular lecture. The first one is coal and ash circuit. The second one is air and gas circuit. The third one is straight water and steam flow circuit. And the last one is cooling water circuit. So these are the 4 circuits of a modern steam power plant. The coal and ash circuit, air and gas circuit, fed water and steam flow circuit, and cooling water circuit. That is under the whole layout is divided in this 4th main part. Look, this is the layout of the thermal power plants. If you follow, I already showed this in some previous figure. So this part is basically the coal and ash circuit. Okay, now air and flue gas circuit is this one. The upper part, the chimney, flue gases. This is under air and flue gas circuit. Now this part is the fed water and steam flow circuit, and finally the cooling water circuit, the lower circular part. So today I will discuss on this 4th part, the main and major part of the steam power station. So first let me talk about the coal and ash circuit. In case of coal and ash circuit, if you follow the figure, you will find that there is a the boiler, the coal storage plant is there, then coal handling plant, and it is connected with the boiler. And from the boiler is also directly connected with the ash handling plant, and finally there is a ash storage. So this part is mainly called the coal and ash circuit. Now, the major thing of this coal and ash circuit is it comprises of coal handling equipment and ash handling equipment. Coal is supplied to the boiler. Yes, coal is supplying to the boiler this part from the storage point by coal handling equipment. From this part, coal storage to coal handling plant, then it is going to the boiler. Steam is generated in the boiler. So steam is generated in the boiler. In this boiler section, the steam is generated. You all know that already. Have some idea, basic idea on this. And ash resulting from the combustion of the coal is removed to the ash storage yard through ash handling plant. So it is going to the ash storage plant through the ash handling plant, and you all know that this ash is basically using for different types of purposes. We use this ash to make the cement which we use to construct the buildings. For making the cement producing companies, manufacturing companies, they just purchase the ash from the power plant, and they used to make the cement. They use this ash. So this part is basically called the coal and ash circuit. Now when we are moving to the next slide, that is called the air and gas circuit. The top part where the chimney is connected. So first try to understand, air is blown to the combustion chamber by induced draught fan or forced draught fan or both. The dust present in the air is removed by dust catching devices or precipitator. Here, look, the air is coming to the boiler, and this is the flue gases. Okay, air is coming to the boiler, then the flue gas is going to the superheater. From the superheater, it is going to the economizer, and from the economizer, is going to the preheater, air preheater. From the air preheater, it is again coming to the boiler. So in this way, this path is circular, and air is coming to the preheater, and finally from the air preheater, the flue gas is going to the chimney. To chimney, it is going to the gas is going to the environment. So this is the process of the air and gas circuit. Now the induced dropped ID fan helps in sucking the exhaust gases and exhausting them through the chimney into the atmosphere. Then the heat in the exhaust gases is partly extracted by passing, number one, through the economizer to preheat the water, and then through the air preheater for heating up the incoming air. So this is the overall work done by the air and gas circuit. Now ID and FD fan. So it's a balanced dot figure. This is in this area the FD fan is placed. Here the FD fan is placed, and in this place the ID fan is placed to connecting between the air preheater to the chimney. Now the fed water and steam flow circuit. If you follow this circuit, you will find that boiler, from the boiler the steam is going to the supply heater, superheater, then through the main valve it is going to the turbine, and from the turbine the exhaust steam, then through the condenser, it's a circular path, through the cooling tower, again through the circulation water pump, it is coming to the condenser. So this is the whole process of the fed water and steam flow circuit. Now the high pressure steam produced in the boiler is used to operate the turbine. Yes, the exhaust steam is condensed in the condenser. So this is already shown in this diagram. The condensate is heated in the fed heaters using the steam trapped from different points of turbine, and finally the condensate is pumped into the boiler. So this is the process, very basic and general process of feed water and steam flow circuit. So just try to remember the circuit diagram, then it will be helpful to understand that what is the purpose of, what is the actual meaning, and what is the working principle of the feed water and steam flow circuit. So from the boiler it is going to the superheater, the steam is going to the superheater, from with the main valve it is going to the turbine, and then exhaust steam going to the condenser, and through the cooling tower it is again coming to the condenser through the circulation water pump. And this part is the river or the canal. So fed water and steam flow circuit. During this process, a part of steam and water is lost by passing through different components, and this is compensated by supplying additional feed water. And this fed water should be purified before supply the prevent scaling of tubes of the boiler. So this part is the additional part. The flue gases coming, look here, the boiler to the flue gases steam turbine, then flue gases feed water, it is coming to the boiler pump, then low pressure heater, circulating water pump, the cooling tower. This is the part. Okay, so additional part is there. This fed water should be purified before supplying to the prevent scaling to the tubes of the boiler. Now, cooling water circuit. If you want to learn about the cooling water circuit, you have to understand this part. The circuit is very easy. That is the lower part of the previous figure. Through the condenser, it is coming to the cooling tower, and again it is going to the condenser. The exhaust steam entering the condenser is cooled by circulating the cooling water. The cooling water supply to the condenser helps in maintaining a low pressure in it, and then the cooling water may be taken from any source like river, lake, or alternatively same water may be cooled and circulated again. Based on this, circuit is divided into two parts. We'll discuss it later, the open system and closed system. So let me talk about first the open system. Look the figure, the open system, the mass out, mass in, energy in. So in this way the system is designed. So what is the system actually? Look here, water from any natural sources like river, sea, pond, and anywhere the canal is used to for condensation of steam in this open system. Yes, water from the upstream of the river is taken and circulated in the condenser. The heated water is let down into the stream of river in this system. So this is actually the open system concept. Now the closed system. So as per the figure, it is divided into 9 part. Look, 10 part. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Number 1 is the surface water, that is 25 degrees centigrade. The vacuum chamber 3% to 1% of atmospheric pressure. Number 3, turbine. Number 4, generator. Number 5, line to the grid. Number 6, desalinated water 23 degrees centigrade. Then condenser. Number 8, deep water 5 degree, and wastewater 7 degrees centigrade. Then vacuum pump. So these are the 10 part. Now try to understand that what is the closed system. When enough quantity of water is not available in the same water will be used in the condenser. If the open source is not available, then the same water we have to use. The heated water from the condenser, yes, because sometimes it is not possible to take the open sources. So in that condition, we have to use the water. For that reason, we need to use this closed system. The heated water from the condenser is cooled by cooling tower or a spray pond and circulated. Makeup water is added periodically to cover the water steam losses. So that's all about the closed system. Now the choice of steam conditions depend on few conditions. Number 1, the price of coal. Number 2, the capital cost of the plant. Number 3, the time available for erection. Number 4, the thermal efficiency obtainable. And number 5, the station load factor. So depending on this, we have to choose the steam conditions. So to make this PowerPoint presentation, I take help from the book of VK Math and Rohit Math, and also this link helps us a lot to make this PowerPoint presentation. And finally, I'm giving thanks for watching this video. If anyone have any doubts, let me know. I'm always there to clear the concept. Thank you again.